So my name is Wang. I graduated with a PhD from University of Illinois at Urbana-Champaign in computer engineering. I've been working in the software and internet industry for a while. I joined OpenAI in 2017, where we first looked into in combine a large-scale massive compute with some existing algorithms to see if we can develop something new and more powerful than that. I think I get attracted by the open-endedness because it sounds like a radical idea to some of the researchers, right? So because we know that machine learning and AI is very good at solving given challenges, like computer vision task, you always have a label for your object, right? You just need to the AI will recognize that because you gave them the answer, okay? And even for reinforcement learning, the tasks are also given. You have been offered a Go game or a Atari game, and the agent, or the AI is driven an agent to solving that. But open-endedness is not about just solving the given challenges. It's about creating challenges and solving them. Create diverse and increasingly diverse and challenges and challenging problems, and then find a solution for it. So we think that it frees the people's burden, the burden on human to design new tasks or new challenges to train a better AI system. Why not we have a system that can invent its own curriculum, invent its own problem, and make itself better by learning from the problem it invents.
Yeah, sounds very cool. Could you give an example of this open-ended?
Oh, okay.
Yeah.
Cool. So this open-ended system, actually, I have two good examples for that, actually. Not necessarily with the machine learning AI, probably more general. So I think first, natural evolution. It is an open-ended system, right? It starts from life, actually start from as humble as a single cell animal, okay, right? And it's actually, after billions of years of natural evolution, it grows into exponential life forms, right? I think it is because Earth offers a lot of various type of challenges for lives, and then life adapts to it, and then lives move from one challenge to another challenge, and eventually they get very complicated and capable. I think it's also more importantly is we're all talking about artificial intelligence reaches human level, right?
Yeah.
Which is we are far away from it. But human level intelligence is created by natural evolution. So at least we know that there's one way of creating it. So this is through open-ended system. So I think that's one example. Another example is, I think, all the human innovation history, like how human, how this innovation drives the human becomes our society becomes this powerful and diverse today. It's really about innovation. And innovation, there's no objective, right? There's no specific goal you want to reach, or your original goal was not that, but you eventually reach something very interesting. Like for example, you can light a fire and then you kind of heat your food, right? That's one way of doing it. But you keep doing it, it will always involve light a fire, right? But people try some other task. They found microwave and they use this radio waves to detect stuff. And later on, they comes back to the food heating problem. I find out that microwave can use to heat food.
Yeah.
So it is very open-ended in that sense, right? So we want to borrow the concept from natural evolution and innovation history of human to help us create a more open-ended, more creative AI system.
Yeah, great examples. So what are some existing exciting projects you are working on, and are there any current challenges?
We are currently working on, of course, we're continuing working on the open-ended algorithm that I presented just now.
Yeah.
My talk was around the creativity of machine learning, right? So because current machine learning often solves given challenges, and they can extrapolate a little bit. For example, their famous system called GAN, right? You show them some pictures of a human face. It learns how to generate a new picture of human face, right? And sometimes it's getting really good that you generate fake human face. That actually creates a problem for us. But it's good at that particular task. But Gang can only extrapolate from the things that he has ever seen, right? On the other hand, evolution is much more powerful, right? You can't imagine Gang could extrapolate a single cell thing growth into human, right? That's too much, okay? But evolution can do that. But obviously with a lot of effort and years of evolution. So I think that's why this is a fascinating research area we'll continue to work on. So the next step of change is we already have a system that can prototype this idea. So how we can make it better? How we can first use less compute, right? We use a lot of compute in our first workshop and use less compute. Second is we have a way of creating new challenges, but that is very limited. The whole challenge is described by a 5-dimensional vector, okay? It's very limited, but for example, can we use a neural network? Again, a neural network to be a painter, to paint these challenges, right? And then we have a neural network as an agent to solve them. Okay, this will be more interesting. So there are all kinds of fascinating ways of extending this research. And also we are looking to ways of apply this kind of concept, right? If we could come up with a good simulator, right, which can create more realistic things, we could use this to train robotics, right, and handles other challenging problems, right? It's really depending on the applications.
Okay, thank you. Sounds very exciting. Thank you for participating.